All right, you guys, here we go. We have a multiplication puzzle for you and for me, okay? First time trying to figure this out, and let's see what it is. All right, we have some numbers in this table, okay? And what do we got to do? Well, let's check it out. In this multiplication table on the right, the row and column headings are all missing. Oh no, see that? This row, the headings are all missing. This column, all the headings are all missing. And only some of the products in the table are filled in. So what are they talking about? Well, this product's filled in. Oh, that would help us get this and this. This is filled in. Oh, that would help us get this one and this one, but that one would have to match with that one. Oh, man. All the numbers in the table are positive integers. That means they're all positive numbers. Like, they're not negative 15 and negative 18 and negative 20 and negative 56 and negative 40 and negative 60 and negative 24 and negative 20 and negative 10. No, they're all positive numbers. And integers, they are whole numbers. There's no decimals or fractional numbers in here, okay? So what is the value of a plus b plus c plus d plus e? Oh man, to figure out a plus b plus c plus c d plus e, I'm going to have to know all these headings on the row and the column. Okay, so let's try and figure this out. So my advice to you is to pause the video and draw out that table yourself on something. And take some time yourself and try to figure this out. If you run into an issue, just scratch that and start over. Try and learn from your mistakes, okay? All right, here we go. I'm taking a crack at this. All right, I'm gonna erase this and just start in because I'm so excited. I just want to start. Okay, I need a pen. All right, so first, A. Well, I don't know what A is because I don't know what times what. Okay, so I don't just want to guess anything. So I'm going to go here to 10. And I'm going to say, in this row, I need to get a 10 and I need to get a 20. So I could put a 1 here. And I know 1 times 10 is 10. And 1 times 20 is 20. But the thing is, will that just keep working for me here? If I go down to the columns, 10 times what is 20? And 20 times what? Okay, that's not given. 20 times something is 60. Okay, there are some good numbers to use there. I could fill those in, should we? 10 times what is 20? Well, 10 times 2 is 20. Now, I'm going to go here into this column because I see a 20 and I see a 60. So 20 times what is 60? Well, 20 times 3 is 60. Okay, and that's all I could fill in. So now I'm going to go to the second row, see if I can fill in some stuff here. So what numbers, what factors can I use for 15 and for 40? What are some common factors of 15 and 40? Well, 1 and 5 and I think that's it. So let's say I put a 5 here because that 5 is a factor of both 15 and 40. So 5 times what is 15? Well, 5 times 3. But if I do that, I run into an issue, you guys, because 3 times 3 is not 18. Oh, man! So I'm going to go back to my top step here. And I'm just going to go from here. And I'm going to have to start with a different factor pair because that ended up not working. So let's say I go 2. They're both even numbers. So 2. So instead of a factor of 1, I'm going to do 2. 2 times 5 is 10. And 2 times 10 is 20. Okay, I'm going to go with this. I'm going to go down this column. 5 times what is 20? Well, 5 times 4. And then I have this 60 I can figure out. 10 times what is 60? 10 times 6 is 60. Okay, this is looking good. Okay, now I'm going to go to this row and I'm going to put in my 5 here because I like that. They both have a factor of 5. Otherwise, it has to be 1. So 5 times 3 is 15. And guess what? I am super excited because it looks like it's going to work with that 18. So let's check it out. 3 times 6 gives me 18. Yes! So it worked this time. Is it going to work over here? 5 times what is 40? 5 times 8 is 40. Things are looking good. Now, are there any numbers left in this column? Yes, this 56. So I'm going to say, okay, 56 I need to be able to get by doing 8 times what is 56? Oh, that's one that a lot of people forget. 8 times 8 is 64, so 8 times 7 is 56. And 8 times 7, that's a cool one to write if you write it from big factor to small factor. Big, 8, times small factor, 7, is 56. 8, 7, 5, 6. It's almost in order. Okay, anyway. Anything left in the puzzle to make sure it all works out? So I have my 10, that works, 2 times 5. 20 is 2 times 10. 15, 3 times 5. 40, 5 times 8. 18, 3 times 6. 60 is 10 times 6. 20 is 4 times 5. 24, okay, I have a missing factor here, right up here. So 4 times what is 24? Well, 4 times 5 is 20. So if I add another set of 4, that would be 24. So I am at 4 times 6. I would need 6 sets of 4 to give me 24. And then I have all of it working. So now I can get my answer to A plus B plus C plus D plus E. All right, A looks like it is 2 times 3, which is 6. Then I have B, which is 5 times 5. And then I have C, which is 6 times 8 is 48. And then I have 4 times 10 for D, which is 40. And then I have 7 times 6 for E. And that one is very close to 40. It is 42. Okay, now all we have to do is add these together. Whew. Well, I am liking. You can add these in any order. That's what's nice in math with the commutative property of addition. I could take 48 and 42 and put them together. And it's going to be real nice. I'm going to love it because 8 and 2 give me 10. So I know I have 40 and 40, which is 80, and 10 more is 90. So far I'm at 90. Okay. Okay, so 48, 42, gone. That's 90. Okay, now what do I like adding next? Well, might as well add 40 more. If I add 40 more, I'm actually going to break 40 up into 10 and 30. Why? In my head, it makes it easier to add because I can take 90 and 10 and get 100 and add the 30 more and be at 130. Okay, so I dealt with the 40. And now I just have to add 25 and 6 more. Well, that's 6. I'm going to break that 6 up in my head into 5 and 1. And why would I do that? Because 25 and 5 gives me a nice 10 number. That gives me 30. And then I can easily put that with 130. 130 plus 30. Well, 30 and 30 is 60. So I'm at 160 plus 1 more, which is 161. And that number is really cool. It's the same forwards as it is backwards. A palindrome happening in math. And booyah! We just accomplished that puzzle. So hopefully you kept on trying with that. and you saw how I solved it. Maybe it was the same kind of way that you solved it, or maybe it was a little different. Did we both end up getting the same factors and that same final sum? I hope so. All right, talk to you later, everyone.